Hello, my name is Andoni Arregui from GTD, and in this talk we are going to address a somewhat unusual topic, data coverage for human-rated flight software. We're going to address here the motivation behind such a thing like data coverage. We're going to see where we can find data within flight software, and we are going to present the tools that we have developed for this purpose. Let's go and see what motivates this. Some of you may remember the very famous issue with the first Pentium 75 processors back in the 90s, the so-called Pentium FD bug. Well, as in this example, sometimes software errors are not related to instructions, but they are related to data. This error was detected in 1994 while doing some numerical computations by Thomas Nicely. The division algorithm within the Pentium processor was based on some lookup tables that mostly worked very well, except for those areas where it completely failed. This had a huge impact on Intel as a company and also on its shares. In fact, about 30% of the software bugs in aerospace software can be attributed to data. About 15% correspond to configurable data and about 15% to input data, be it in the form of sensor data or commanding input. It has been assessed this way by Lorraine Prokop from NASA. The challenge we have nowadays is to see how we handle this. As we see our present and near future full of human-rated missions, or of missions that at least require human-rated software. The Artemis program is an obvious example of this, but many other missions such as Mars Sample Return, Clear Space 1, for deorbiting also need this kind of software. And the standards we usually work with, be it on the European side the ECSS standards or the NASA NPR standards, do not really have specific requirements for data coverage apart from some general statements where it is required that all the data defined for a certain mission shall be validated. Why is that so? You will know the joke about the man looking for his lost keys under the streetlight, not because he lost them there, but because there was no light where he lost them. This case is somehow similar. We have many tools to assess structural coverage of instructions by testing, but we have practically no tool to assess if the data present in the software has been really used by the test we defined. So where do we find data within flight software? If we take a look at object code, it's not so easy to distinguish where the data is and where the instructions are, as we can see on the example we are seeing here. This would be the bytes where we have instructions, and this would be the area where we have the data. We can only know this because in this case we know the source code that produced this object code and we know how it was compiled. But we also have all the data around the flight software. We have data that comes in via sensors or via operator commands. All of this data also affects the behavior of the flight software in the end of the day. Well, so what we did is, to try to help here a bit when it comes to verifying the data, we developed a couple of open source tools. Under a contract of ESA, we developed these open source tools to be able to help the projects to gather coverage data, mainly by executing the unit tests that have been defined. Just to see an example here, we have here a function defining an exponential function. And in order to achieve all the required metrics for critical software, we would need a test set of about 20 unit tests that would already achieve complete statement, decision, and even MCDC coverage. The only non-covered orange point you see there is just some deactivated branch there that would never execute in round to nearest mode. But else we would achieve complete structural coverage with 20 unit tests. With the tool we developed, we can log all the data that has been exercised with this set of unit tests. And what we see is that only very few data points have been really exercised with this else exhaustive unit test suite that we would have defined with these 20 unit tests. This means that we do not properly exercise the data that has been defined within this function, even if it is a critical software where we achieved the highest metrics required by such a software. Another tool that we developed enables us to gather and monitor data coverage, especially for memory sections and memory areas of interest. We can monitor then the use of data within the data section, within the BSS section, and so on, and also on memory areas such as the stack. This can be used, for example, when we want to check if a certain Monte Carlo testing campaign has exercised all the data that we specifically defined for a certain mission. And now a couple of takeaways just to conclude. As we have seen here, even for human-rated flight software, data is not treated on the same level as instructions when it comes to verification of the flight software. The lack of tools play a substantial role in this, and this is where we wanted to help a bit, developing the tools that we have been developing. These tools enable the projects to check whether the data that has been defined for the flight software has been also properly exercised by the tests that have been developed. If this caught your interest, please contact us. We will be very happy to help. Thank you very much.